Okay, we are still working from the course 2 textbook. We are doing lesson 5.2 extension. Now you do not have this textbook, but you do have access to it through your Big Ideas online. You've got access to this textbook and all the pages for the lesson are attached to the agenda. So we're going to build on what we learned yesterday. The textbook is going to give us a table that looks like this. Time X, which is seconds. Height Y, which is meters. And we're going to go 3, 2, 6, 4, 9, 6, 12, 8. So the book is giving us this table. Okay, we want to know, are X and Y in a proportional relationship? Or are time and height proportional? And remember we said a proportional relationship means, what does it mean? Equivalent fractions. So a proportional relationship means equivalent fractions, right? So I don't see any fractions here. We're going to need to make our own fractions. Now, typically when we do that, we put X over Y. Seconds over meters. And here's our fractions. 3 over 2. 6 over 4. 9 over 6. And 12 over 8. So we took our ordered pairs, our X and Y's, and we turned them into fractions. And we want to know, is it a proportion, is X proportional to Y? Is the seconds proportional to the meters? Is this a proportional relationship? Are they equivalent fractions? So yesterday we learned we can reduce the fractions. 3 over 2 is already in simplest form. 6 over 4 can be reduced. Oh, to 3/2. 9 over 6 can be reduced. Look at that, to 3/2. And 12/8 can be reduced. Oh, all of my reduced fractions are 3/2. These are all equivalent fractions. They are proportional. Proportional. We also learned we can turn the fractions into decimals. We can set them to 1 or turn them into decimals. So 3 divided by 2 is 1.5. You can use a calculator for this. 6 divided by 4 is 1.5. 9 divided by 6 is 1.5. And 12 divided by 8 is 1.5. When we turn the fractions into decimals, they are all the same. They are proportional. So this is everything we did yesterday. The new stuff we're getting to is we're looking at graphs. Is the graph proportional or not? If it's proportional, what's the unit rate? So we need to start looking at graphs. So I'm going to turn this information into a graph. Now it's already telling me what my X is. My X is time in seconds, and my Y is the height in meters. So that makes it pretty easy. Here's my X, and here's my Y. They already told me X is time in seconds, and Y is the height in meters. Because some people ask, well, how do you know which one goes where? Well, they're already telling me the time is X and the height is Y. So the time is on the X-axis and the height is on the Y-axis. And creating the graphs, this is the most time-consuming part. Okay, now we need to graph our points. And this is kind of nice because this is an X and a Y. These are ordered pairs already. X, Y, X, Y. These are already set up as ordered pairs. So we're going to graph these points. So we have 3, 2, 6, 4, 9, 6, 3, 2, 6, 4, 9, 6. I don't have enough room to graph 12, 8, but that's okay. Use a straight edge to connect your points. So graphing is nothing new either. You guys know how to graph points. We've been doing that. So let's take a look at the things we know. We know that slope is the rise over the run. So let's go ahead and do that. Here's my 2 points. I'm rising and I'm running. Oh, look at this. I'm rising and I'm running. So my rise is 2 and my run is 3. So my slope is 2/3. We know that. Now, the new stuff. We already reduced the fractions and turned everything to decimals. We know this is a proportional relationship. But how do we know it's proportional by looking at the graph? Well, we have a straight line. We have a slope. The line right here goes through the origin. If you have a straight line with a constant slope that goes through the origin, then it is proportional. It has to go through the origin to be proportional. Now, let's talk about how to interpret these points. So we have the point 32. What does this point mean? When we read the points, we read the y first, then the x. So this means the height is 2 meters at 3 seconds. So let's take a look at this point. What does this mean? The height is 4 meters at 6 seconds. And the way to remember this is we read from left to right. So we read from left to right. So we usually state the y first, then the x. And that's going to make sense in just a second. Because this is proportional, it goes through the origin and our slope, we can describe the unit rate. The unit rate is the slope of a proportional graph. So the unit rate is the slope of a proportional graph. If it is not proportional, you do not have a unit rate. So what is our unit rate? Well, the slope is rise over run, the change in y over the change in x. It is meters, my y is meters, over my x is seconds. My slope is 2 over 3. So what is my unit rate? The unit rate is 2 meters per 3 seconds. Okay, we have one more example. This is what a proportional graph looks like. It goes through the origin. And if it's proportional, we then have a unit rate. The unit rate is the slope. But what does a non-proportional graph look like? Well, let's do it. So this time, the book is giving us the example. Hours worked over dollars X over Y So this time the book's giving us a horizontal table. And they're asking us, are the hours work proportional to the dollars? Is the X proportional to the Y? Do they form equivalent fractions? So I need to make my fractions. X over Y, hours over dollars, there's our fractions. So like we learned yesterday, we know we can reduce the fractions. We can reduce them to their simplest form. To see if they are equivalent or proportional. Uh-oh. 1/3, 1/2. We can reduce this. 3/5. Whoa, take a look at that. When they're in their simplest form, they are not equivalent. Not proportional. We also learned we can turn the fractions into decimals. So this is 2 divided by 6. That equals 0.33. 4 divided by 8 is 0.5. 6 divided by 10 is 0.6. Look at our decimals. They are not the same. They are not proportional. So we know that by looking at the fractions, reducing our fractions to simplest form, or turning them to decimals, that we do not have a proportional relationship. But what does that look like in graphing? Okay, what does a non-proportional graph look like? So let's do it. So they told me that hours worked was X. So I'm labeling my x-axis hours. They told me that dollars was Y. So I don't have to think about what I'm labeling my axes. They've already given me that information. Creating the graph is the biggest pain. Okay, now we need to plot our points. And they've given us our X's and our Y's. So we have 2, 6. We have 4, 8. And we have 6, 10. And I'm going to use a straight edge to connect my points. They are points, not dots. And there's nothing new here. You guys already know how to graph your points. There's nothing new here. So let's take a look at the things we do know. Let's take a look at the slope. We know that the slope is the rise over the run. So let's do that. We are going up 2, over 2. We are rising 2, and we are running 2. So my rise is 2, my run is 2. 2 divided by 2 is 1. My slope is 1. And what that means, I go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. So yeah, that kind of makes sense. So we've got the slope. We know how to do that. But let's take a look. Where does our line cross the y-axis? Right here. This is 0, 4. This is our origin. This is not the origin. Because our line is not crossing at the origin, it is not proportional. Here's my origin. This is where my line is crossing my y-axis at 0, 4. This is not the origin. So this is not proportional. But how do we describe each point? So let's describe the point 2, 6. What this means is we have $6 at 2 hours. Let's take a look at the point 4, 8. So we have $8 at 4 hours. Let's take a look at 6, 10. We have $10 at 6 hours. And unit rate, the unit rate there is no unit rate. Because this is not proportional, there is no unit rate. We still have a slope, but this is not a proportional relationship. And because of that, we do not have a unit rate. So that's the new stuff for today. We're graphing the points, which is not new. We're finding the slope, which is not new. We're checking to see if the line crosses at the origin or not. That is new. If it crosses at the origin, it's proportional. If it does not cross at the origin, it is not proportional. We know how to describe the points. So $6 at 2 hours, $8 at 4 hours. We know how to describe the points. And if it's proportional, the slope is its unit rate. If it is not proportional, there is no unit rate. So this is the new stuff for today.